Which one was it?
75, 70.
70. Thank you, miss. Oh, okay. All right. So we did that one yesterday. Were you here? You were here. Yeah. 74 point. Oh, I'm looking for 4.5. Yeah, I'm looking at the biodiversity one. 4.5. Here we go. Ooh. One quick thing about EDX, a little side note before we do number 70. Alright, so a little side note. What's interesting about the solutions to this equation?
Natural law.
You could use it to solve it. And maybe that would show you what's true about this. Yeah, what's true about e to the x? Where's there an asymptote for e to the x? For anything to the x? Where's there an asymptote?
Along the x-axis.
Good, along the x-axis, which means the output can never be 0. So this equation is saying, when is the output for e to the x 0? So there is no solution. Cool. So when you're solving an equation equal to 0, if you have an e to the x piece, you throw it out. It's not going to give you any information. It's never equal to 0. So what's this got to do with this? It's also always positive, right? So you've got to keep that in mind when you're doing inequality stuff. So number 70 says, so really the funny thing about e to the x with solving equations or inequalities, it's one of the few functions you're completely allowed to just divide by. You got to be careful. It can't be. I mean, if it's just e to the x, you're fine. If it was e to the something and it has been shifted or something, you got to be careful. But how do I factor this? Let's do it this way. You take an e to the x out.
X squared minus 2.
Yeah, is that x squared? Or did I make that up? No, it is x squared. Okay.
Minus 2.
Okay, cool. So the nice thing is, I want you guys to realize, there's no way that e to the x can be less than 0. It's always positive. So it actually doesn't really factor in. So how do I do this kind of problem? How do you factor this? This should be old news for us right now. We're in chapter 4. Yeah, say it again.
X plus the square root of 2.
Good.
X minus 4.
So how do I solve this kind of problem? No, I can't do that. Number line, put your zeros on it.
Yeah.
The question is, where is it negative, right? The beautiful thing is that doesn't even come to play because it's always positive. So if you draw your number line, your zeros are negative root 2 and positive root 2. They're both multiplicity 1, right? Oh man, it all comes back. This stuff never goes away. Just because we're not in that section doesn't mean it's not going to be useful. Right? The minute you learn chapter 3, it's basically always useful. So if I plug a 0 in, what sign do I get?
Negative.
Yeah, I get negative. Good. So it's negative, and then it's got to, since it's an odd multiplicity, what's it got to do here?
Change sign.
Change signs. Change signs. So what's the answer? Where's that less than 0?
Between.
Yeah, between those two. Including or not?
Not.
Not including, because you're not allowed to equal 0. So it'd be negative root 2 to root 2. Cool.
Root 2.
Root. That's a highly technified way of saying it. That's my George's accent.
just played with the multiplicity. Root 2.
Yeah, exactly.
Basically, it's looking at
The multiplicities kick ass. Now, of course, I'm waiting for somebody just to tell me there's a really much easier way to do this just because it's quadratic. It's a parabola. So where's a parabola that opens up negative in between its intercepts? Right? So you actually don't have to do all this work. But since nobody brought that up, we did. So whenever you have a parabola for this kind of question, a parabola that's asking you less than 0, greater than 0, anything like that, you could just reason that out. You could draw a quick little figure and say, there, if it opens down, the answer would have been outside its intercepts. That's where it would be negative, right? Okay. Maybe. Or you could just always do this work. That's great. Nothing wrong with it. I love the background noise we have going on.
No.
As long as we get that out of the way now, right? Tomorrow, we don't want that shit.
If we have it today, we have to have it tomorrow.
We're going to have it tomorrow?
Yeah. If you do it while you're studying, you'll hopefully send the test.
You can hide messages in the sound.
Exactly.
Yeah.
Problem number 9, 4.5.
Oh, yeah. All right. This is neat. So, again, anything that's after where it says discovery, discussion, writing, it's going to be something maybe just a bit freaky. Right? They tell you, this is the one, the surprising equation, right? Or the x to the 1 over log x, that one? But what, do you have the problem written down?
Yeah. It's an x to the 1 over...
That one, okay, good. I just want to make sure before I launch into it, I get the right problem. X to the 1 over log x equals 5. Okay? So they tell you what to do. They tell you what to do. Take logarithms. And now, why would I take logarithms here?
To get the exponents down.
Yeah, because I want to get that thing down. So try it. Do it. Take a log of both sides. Don't do it ln. Why would I maybe do a log? There's already a freaking log in there. So maybe they'll do something together. Okay. What did you guys get? If you take log of both sides, what happens? 1 over log x comes down, right? That comes down. Times log x. So you get 1 equals log 5. Is that true? I would bet not, right? Alright, so there, the part A it said straight up, show that it has no solution. Okay, cool. There, I showed it has no solution. And then the more interesting part says, for what values of k does the equation x to the 1 over log x equals k, when does that have a solution?
How do we figure that out?
You do the same thing you did. They gave you the pattern of what to do, right? So for what value of k does this have a solution? We actually kind of already know what it has to be, but if we do the whole process again, take log of both sides, what do you get? This comes down, cancels that, we get 1 again, right? When is 1 equal to log k? What's k got to be?
10.
0.
10.
I don't know, right? That's sort of it's got to be 10. Base is 10. 10 to the first equals k, so k has got to be 10 in order for this to have a solution, right? And then the solution would actually be all real numbers. So either this thing has no solution, or all of a sudden, if you make this side 10, it has all real numbers as solutions. Right? Let me see if I want to do this real quick. That is going to drive me a little crazy. Look at 1 over log x real quick. It is log 10 over log x. Let me let you absorb that for a second. Is that true? Yes. Remember we talked a little bit about different ways to represent 1. Didn't we talk about that, or was it another time?
Yeah.
Oh, we did talk about that. Good. I'm not going crazy yet. I'm already there. So that's one way to represent 1. Log 10. And by replacing that with log 10, you guys realize this is the change of base formula. So can I work it back to see what it would have been? What would the base have been?
10.
No. Base is on the bottom.
X.
So it'll be base x of 10. Now watch this craziness. This then, this is equal to, now what did we just say this was equal to? That. And what do these do?
Cancel.
Cancel. So this is 10. So that's why the damn thing only has a solution when you make that side 10, because that is 10, right? It's like saying 2 equals. Now fill that in. When does it have a solution? 2, yeah. And of course they hid the fact that this is 10. That doesn't look like 10. But holy shit, there's a way to represent 10. If you want to freak your friends out. I was x to the 1 over log x years old when I discovered him. But you were what? What time is it? X to the 1 over log x? I'll go ask somebody else. Thank you very much. Anyway. Freaky. Anyway, that I spent way too much time on. Let's get back. You're not going to see that on the test. Maybe bonus. Maybe give me an idea for bonus. Anything else from anything pre-calculus related, preferably?
35.
Which one?
35.
35 and 4-5?
Yeah.
All right, good. So this is what I was saying earlier. Okay. So we got 4x cubed e to the weirdness minus 3x4 e to the weirdness equals 0. So you don't freak out. I mean, how do you solve an equation like this?
Grouping.
I don't have 4 terms. I have 2 terms.
I mean, factoring.
Sure. What kind of factor?
Take out your GCF.
Good. So you can take out 3 x's and e to the negative 3x.
And you're left with 4 minus 3x.
Yeah, good. 4 minus 3x. So either this is 0, or this is 0, but this is never 0, so I don't even worry about it. I can divide by it, because I can divide by anything that's not 0, and that's never 0. So hey, that's another reason why I see way too much of this. No. I mean, you can argue that is one right answer, but by doing this, you lost the other answer, which is 0. You can't divide by x because it could be 0. Here, I could divide by this because it cannot be 0. 0 eats it up. So then I'm just left with this. Or you just leave it there and say, you don't tell me shit, and just move on. So what's the answers? X could be 0. Or x could be 4 thirds. Yeah. Yes, sir.
Just understand, anytime there's e to the x power, we just divide it out, it's going to be negative.
Yeah, exactly. Because e to the x, one fundamental property of it is it cannot equal 0. It's got an asymptote there, so it can't be 0. Cool. You're welcome.
I hear everything.
I know. I told them like years ago about a stupid thing, and they're like, "Oh, we'll tear that building down anyway. Who cares about the vents and the doors?" Okay, yeah, sure. And then we lost all the money. So.
He's going into the new tennis courts.
Huh? Well, let me say it this way. Then we stopped getting money.
Why is there a door?
Huh? Oh, you don't want to know.
So now we do.
That's from the old days when students were bad. Solitary. Get in there. Those were fun days.
So it's not the midget door?
Huh?
So it's not.
Oh, I've seen way too many horror movies to even think about the fact that there's a door there, so stop it. Like Tales from the Dark Side, if you've ever seen that, it's horrible. You know which one I'm talking about? Yeah. God. Alright, so, anything else from the practice test? Homework? Yes?
I'm looking at number 6 on the practice test, and I'm just trying to remember how, is there a shortcut way to figure out what it's going to look like? Or do you just have to plug numbers and chug?
You fundamentally know what it's going to look like since the bottom factors, it has real solutions. So you know it's going to have 2 walls.
Yeah.
But you don't have a general sense
You
of...
don't have like an end behavior type deal.
Not truly.
Okay.
Not. I mean, there sort of can be, but no.
On this one I would have assumed because the bottom is a parabola, it would be parabolic, but it's not at all.
No, yeah. The bottom actually has not as much to do with the shape of it.
As
The top does, but then it doesn't have directly much to do with the shape.
Because
So
You
the
just
simple
gotta
answer
play it.
is no. There's no way. So let's do this before I forget, because I already did forget. We got to do the ones that I haven't done on the answer key. So starting with number 7. What kind of asymptotes is number 7 going to have?
Slants.
Yeah, so I have vertical and it won't have horizontal, it'll have slant. And how do you figure out the slant asymptote? Long division. So let's just take what I've done. Hopefully you guys could all do that too. So what I discovered, because the one thing I didn't do on there was graph it, because I didn't feel like copying a third page, so I just went to 2. I figured out, pretty much, that the x-intercepts were 0, 0, and where do you got? Negative 3, 0. They're vertical asymptotes. So this is also the y-intercept. Vertical asymptotes at 2 and negative 2. This is number 7. And I did the long division, so I figured out the slant asymptote is y equals x plus 3. So that's what the thing has to approach at the ends. Right? It's sort of like its end behaving the way, because it's diagonal. What am I trying to say here? Blah, 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 blah. Oh, so we got everything we need. We can start to graph this thing. So to be careful about our scales, the x-axis will almost always be pretty decent. I just have to be able to, let's see, 1, 2, 3, 4, 1, 2, 3, 4. That's nice. Y-axis I'm not too sure about yet. I don't even have a y-intercept to help me out with that. So I put in everything I know. I got a intercept there, I got a wall there, intercept there, intercept there. So now I got to get a quick feel before I plot this. I want to figure out what my scale here is going to be. So what points might I need? Yeah, it might be a good idea to get negative 1 and 1. This came from a multiplicity of what?
3.
2.
Yeah, the multiplicity was 2. So what's it going to do here? Turn. So figuring out, at least one of these is a good idea. If that's here, then I know it's going to turn. So I can figure out what f of negative 1, f of 1. Now I'm going to have my slant's going to come in sort of like this, depending on what my scale's going to be. It's going to come in like this. So I'm probably going to want to know what f of 3 is. You guys see what I'm saying? Because I got to know where exactly is it here. So let's see f of 3. And also the same way, I've got to know what maybe f of negative 4 is. Just to see where. And what's it going to do here? So here's got to turn.
That's going to go through.
Here's going to go through because it came from multiplicity of 1. You guys kind of with me? I mean, everything comes in at once to help you graph this. So look at it like a lot of things to remember. Look at it like a lot of things that help you. So somebody help me out. F of negative 1. Where's my stuff here? Let's see what's it going to be. 2 over negative. Is it negative 2/3? I'm not going to get much help. Okay, negative 2/3, I think, is what I believe until I hear something different. F of 1 looks like it's going to be 4 over negative 3, so negative 4/3. And that makes sense, right? They're both negative, it's supposed to turn. Thank God. If I would have come up with negative 1 positive, that should be like, oh shit, what did I do? And then F of 3. What else did I say? I said f of negative 14. F of 3 is 54 over 5, so roughly 11. I like how you guys are just taking I should just say something that's complete bullshit. See if anybody tells me. F of negative 4 looks to be square root of pi. No.
3.
So it's 3?
No.
So it's 16 times negative 1. So negative 16 over negative 6 times negative to negative 16 over 12, which is negative 4/3. Hopefully I did that right. Yeah, right. I don't get answers, but at least you get verification. So it looks like my 3 is way the hell up at 11. So, but everything else is really kind of tiny. Let me say 1, 2, 3, 4. So at least I can capture my y-intercept.
Your y-intercept 0.
A y-intercept for my slant asymptote,
Oh.
right? So the next thing I have to do is my slant asymptote. And the y-intercept for that is 3. And then it's going to go up 1 over 1, down 1, back 1. So here's my slant. In fact, it's going to go right through this. That's interesting.
Okay,
All right,
what I was
so
doing.
it's like a curvy slant, but oh well. It's my beautiful scale. All right, so we know what it's doing here. That's cool. So we know at negative 1, it's let's see, 1, 2, 3. Negative 1, it was negative 2/3, so on this side of it. At positive 1, it's negative 4/3, so just on that side. So it looks like this. It turns like that. Cool. Yuck. That's good enough. All right. We know at negative 4, it's negative 4/3, so it's on the other side of. Let's see. Now here's where I got to be careful. This blue line, where would it want to be at negative 1? It would want to be at, what have I done? Oh, negative, sorry. Where would it want to be at negative 4? It would want to be at negative 1. Looking at it backwards. So at negative 4 wants to be at negative 1. And I know f of negative 4 is negative 4/3, a little bit below negative 1. Because the important thing on this side is, am I coming at this like this, or am I coming at this like this? You know, which side am I approaching that from?
Oh, okay.
You guys kind of with me here. I got to know exactly where does that fall. It wasn't, if it was 7, that would have been great. It would have been really easy. But it's really close to the damn blue lines. I had to be a little more careful. And it's going to go through this. And what's it got to do here? It's got to slam. So I know negative 4 is right there. So it's going to come in through here, and I can check it in here if I wanted to, but it can't get there unless it starts here. It's got to go through there. Then it's going to approach that line like that. Crazy. Cool. So that's a really good example. It went through the slant asymptote, which is fine. The slants and horizontal asymptotes don't become, you don't have to enforce them until x gets big. And x is pretty small in here, so it could cross through there all it wants to. All right, how we doing? Okay. All right. Let's see, what else did I do? 13 and 14.
So graph the other stuff.
Yeah, the other side.
What is it? Oh, yeah, this thing. So what do we know about over there? F of 3 is 11.
Yeah, way up in the...
So if I continue that guy, I know it's going to be in here. Yeah.
I was wondering how'd you get the slant equals y equals x.
It's on the. What do you have to do? You have to do long division.
Oh, okay.
Yeah, because when do you have a slant asymptote?
When is the topics?
When the top is bigger than the bottom, and when the top is bigger than the bottom, what can you do? You can do long division. In fact, when they're equal to each other, I'm not going to do this, but what would the horizontal asymptote be here?
2/3.
Yeah, and if you did long division, you would get 2/3 plus some extra piece that would go to 0. But we don't have to do long division. We know the shortcut, 2/3. Yay! Right.
And then if the top.
If it was cubed, then I would have to do long division, and the whole part would be my
And then if it's
slant.
Then if it's smaller on top, bigger on bottom, it's none.
It goes to 0. It would be the
go to 0.
x-axis.
Okay.
Yeah. Yes.
If it's more than multiple of, like if it's x squared on the bottom, x to the 4th,
Technically, this book says it has no slant asymptote, which I guess is true, but it still has, we actually looked at that once. It has a parabolic. It has to come up against the parabola at the ends. So in a way, that does describe its end behavior, of course, because as x gets really big, that's what end behavior is all about. That's the horizontal asymptotes and slants. So it's got to look like a parabola out here, but in the middle, it can do all kinds of weird shit. But it's got to look like a parabola at the ends. Yeah. If it was fourth power over second power. Did you have a...
I did, but I don't. Well, so like with any slant, it's like any linear, so you could have like a 1/2 x plus 3.
Sure.
So it doesn't matter. You just once you do long division, if it comes, however it comes out, that's your.
However it comes out. Right?
Okay.
Cool.
13.
Oh yeah, so 13 should be relatively quick. Yes, sir.
So at the top part, I mean, you didn't like really affect it. Would it go over the line like it did on the bottom one?
No.
Like would it cross it?
It could,
You could, we don't know.
but we don't know.
Okay.
And we don't need that much detail.
Okay, cool.
Yeah. Especially, I really want you guys to see, the scale on your y-axis should not be so large because most of your outputs here were so small. So this is one case where I would let you just kind of give me the shape up there because I wouldn't expect you to draw 4, 5, 6, 7, 8, 9, 10, 11. Yay! I mean, I don't want to see that. Yeah, so capture the idea of it, the shape of it. Make your scale make sense. So I'm getting a lot of people give me, on the homework, they give me these things that are like, I'm like, blow that up. You know, make your scale 1/2, 1, 1.5, 2. Right? Don't make your scale 5, 10, and then have all this crap happening in the middle. I can't see that. Okay. 13. What's the idea with the domain of logarithms? Good. So they're sort of like radicals, right? But the one extra thing they have is they can't even be 0. So I got to make the inside greater than 0. Which means x is
5,
less than
5.
5. I like that. Good. All right. So that's it. That's the domain of that guy. X got to be less than 5. Okay, so let's focus on number 14. This is the relatively new stuff, right? So how do I solve that?
You gotta log it.
Yeah, you can do any log you like, but ln's a good one to do. So if you do ln, and again, the key to learning is repetition. Why do we do that?
So they can bring the x
So
out.
bring
Because the
the
logarithms are the
exponents
only functions that have that property where they can free the x if it's up in the exponent. Beautiful. So now that guy can come down. So the exact answer is
ln
112.3.
divided by ln3.
all right. Good. So on the test, I'm going to ask you for an exact answer, and then I'm going to ask you for an approximate answer rounded to like 3 places or something there. Just make sure you plug this in your calculator correctly. So what do you get if you plug this into your calculator?
4.298.
Who?
Number.
Grab 4.298.
Oh, God. You guys are funny. You keep going at the same. So 4.298.
298.
Okay, thanks. Why does it kind of make sense? What's 3 to the 4th?
What?
81. And 3 to the 5th is 243. So it makes sense that it's in between 4 and 5, closer to 4, because that's closer to 81. You see, so that answer makes sense, right? You should be able to step back and say it doesn't make sense. If you get -3 here, I hope to God you don't leave it. Just see if it makes sense. What about part B? Same thing, except you just got to be a little careful, right?
Different number.
It's the same thing, just moved over a little bit. But actually, you know, what's funny is I hope that you're more than just joking around. I That's something that students don't seem to understand. They treat every problem as if it's a different total thing. No, it's not. They're all the same thing. So, of course, the first step is the same. Then you just got to be a little careful with bookkeeping, right? With keeping track. So the first step, of course, is ln. So you get 2x minus 1 times this equals x minus 5 times no jump. That.
And do you have to distribute?
Yeah.
Yes, good. Right? You have to, because your x's are stuck in here. You got to distribute this number and then get all your x stuff together. So you just got to carry these things along. So you get 2x times this minus this equals x times this. If you want to make that 3.1 minus 5 times this. So get all your number stuff together and get all your x stuff together. So maybe subtract that, add that. Are you guys with me?
Yeah.
Just realize ln 12.11 is a really actually nice way to write what the actual number is. The actual number never ends, so I'm glad I have a nice compact way to write it. It's a number like 7, but it ain't 7. It's just a number though. So I can get my x stuff together, subtract this dude over, get my number stuff together by adding that dude over, and then take an x out and divide by what you don't want. So if I take an x out, I'll be left with that. So I have x equals ln 12.11 minus 5 ln 31.7 divided by the stuff that would be left. I don't want that stuff. I swear to God, it's not 3.17. There you go. And when you put this in your calculator, you gotta be careful. It's gonna open up these stupid little parentheses. It's like Microsoft Word. Let me try to guess what you're trying to do. No, stop it. I'm not trying to do that.
Yeah.
So that would be the exact answer. And then I'm going to ask you for an approximation, just to make sure you're actually able to put this into your calculator correctly. I don't know what it's going to be.
Would be negative.
It's definitely going to be negative.
9.65.
Okay, I like that. We got agreement. Okay, cool. And finally, part C. Part C compared to this is actually probably going to be nice.
Oh, that's nice.
So how do you do this? Good. So you can rewrite this difference of logs as the log of x over x minus 2. Combine those, because now you have log something equals 2, and you know how to rewrite that. How do you rewrite that? 3 squared equals that. So 9 equals that. And then that's relatively easy to do from there, right? Now if I would have had a plus sign in there, you would have had to multiply those. You would have gotten x times x minus 2 equals a number. You would have to FOIL it, bring it over, factor it. The thing with your answers, you got to make sure the answer doesn't do what?
Weird shit.
Weird shit. Weird shit meaning making this 0 or negative, right? So you just got to check the answers to make sure it's not going to make... And don't think that 1 is okay. 1 would be bad. If you got 1 as an answer, why is it bad?
Negative.
Because it makes this negative. Don't say if the answer is negative. If it makes this negative, you got to throw it out. So of course we get 9x minus 18 equals x. We get 8x equals 18. X is 9/4. And how is 9/4 compared to 2?
Bigger.
It's bigger, so that would be fine then, right? If it was 7/4, that would be a problem. Cool. I like it. I'm still saying that. I said that all day yesterday. It's crazy. It's just like stuff. Make this.
Part of the learning process.
Huh?
Part of the learning process.
Part of the learning process is to put up with your teacher's stuff. Yeah, that's for sure. You're gonna ask teachers. If you keep going,
What if we just keep on having you?
then you're gonna continue to have a weird ass teacher. So that completes your answer key, right? Bless you. Anything else?
When you say evaluate log, you just want us to see what.
Yes.
Yes. Yeah, I could say simplify.
Now, as far as like ln e pi, it's just pi, right?
Yep.
We do have a calculator.
What? You could. And wait for somebody to write down 3.14.
When it says 10 log to 11.
Come on, I don't want that. Yeah, add the 18, subtract the x. Yeah. That stuff I'll do quick because I know you guys have to do it. Yeah.
Alright, so number 15 or 4.2. I know
Do we want to do like that? Number 15.
Yeah. No.
Why would then you have to?
You said it'd be 3 log 3.
Oh,
And
okay.
you wanted 4 yet.
You grab
But I don't even think that one yet.
The only one I'm looking at is this one.
both of them. So one of them looks like that, one of them looks like that.
Oh, that's why they cancel. I was like, what?
Just be very specific to yourself. Figure out what one is. So do e to the 1 minus plus e to the negative 1 over 2. Alright, we're doing kosh. Yeah.
What is Coach?
They defined it for you. They told you exactly what kosh is. Kosh is e to the x plus e to the negative x. I could have called it
You got your
of x. This doesn't matter. This is just a function name, like log. Why do they call it log? Because that's what somebody saw. What are we going to call it?
Downstairs rolls over in pairs.
Log. No,
Rolls over your name.
so it doesn't matter. The name doesn't matter.
It's on your back.
Right? It is trigonometric related, but you don't have to even know that because it's based on a function that we know.
Alright.
So that's the definition of kosh, and then you just work with it. Yeah. Thank you. What? Kosh? Could be. Could be some retired math teacher trying to make his own Breaking Bad thing. Forget about math. Here, have some kosh. Maybe it'll be me. I don't know chemistry well enough.
Don't worry about it. It's too many pain in the ass.
Like 4 years,
Just 6
I just
anyway.
plugged in this equation in the calculator and found the intersection.
Show me how you plug that equation.
Do you want me to bring the calculator?
Sure, yeah.
Okay, so I'm gonna do this one's real.